Now we will see the questions of section C, which are 2 numbers question. Each question is having 2 marks. We start with question number 21. Those who have not yet seen my solutions of questions up to question number 20 may see those videos also. Question number 21 is find the number of natural numbers between 102 and 998 which are divisible by 2 and 5 both. See, first we read this question very carefully. Numbers are between 102 and 998. Means we are not to consider 102 and we are not to consider 998. We are to consider the numbers which are between these 2 numbers. Now, number should be such that it is divisible by 2 and 5 both. Means the number should be divisible by 10. So, number divisible by 2 and 5 both, this implies that number is divisible by 10. Now the first number which is divisible by 10 between these 2 numbers is 110. Second number will be 120. Next will be 130 and so on, such that the last number which is divisible by 10 will be 990. Now we want how many these numbers are. Now surely this makes an AP. This is an AP arithmetic progression whose first term is 110, common difference is 10, and nth term, let us say these terms are n terms, these numbers are n numbers, then nth term is 990. Now we have the formula that if A is the first term, B is the common difference, and AP has n number of terms, then Tn, we also write it as An, this is equal to, that is the nth term is equal to A plus n minus 1 into D. This formula we are going to apply. So 990, which is the nth term, is equal to A, that is 110, plus n minus 1 into D. 10 we can take common. So this is equal to 10 in bracket 11 plus n minus 1. And here it is 990. 0 and 0 are cancelled. This implies 99 is equal to 10 plus n. 11 minus 1 is 10. So it is 10 plus n, which gives us n is equal to 99 minus 10, that is 89. So the number of natural numbers between 102 and 998 which are divisible by 2 and 5 both are 89. Now we will see question number 22nd. Question number 22nd. Prove that the rectangle circumscribing a circle is a square. Let us first make the diagram of it. Here we see that there is a circle whose center is O. A, B, C, D is a rectangle, and we are to prove that this rectangle A, B, C, D is a square. That is, its all 4 sides are equal sides. Here A, B, C, D is a rectangle, means AB is equal to DC and AD is equal to BC. Opposite sides of rectangle are equal. Now we know that from exterior point, if we draw 2 tangents to a circle, then they are of equal length. Now we know that since the rectangle is circumscribing the circle, means this is tangent, AB is tangent Suppose this point of contact is P. Similarly, we assume this point as Q, this as R, and this as S. Then AB is tangent to the circle, and this length AT is equal to AS, since AD is also tangent to the circle. So from exterior point A, we can say that AP is equal to AS, both are tangent. This is our first equation. Similarly, from exterior point B, BQ and BP are tangents to the circle. So we can write BP is equal to BQ. This is our equation 2. Again, C is the exterior point. Here CQ is equal to CR. So CQ, this is equal to CR. This is our third equation. Again we find D is the exterior point. DC and DA are tangent to the circle, and tangents are equal length. So DR and DS are equal. So DR is equal to DS. This is our equation number 4. Now we add these 4 equations. So adding equations 1, 2, 3 and 4, we get AP plus BP plus CR plus DR. This is equal to AS plus BQ plus CQ plus DS. This we obtain. Now AP plus BP. AP plus BP is AB. So I can write this sum as AB plus CR plus DR. CR is this length, DR is this. So it is CD or DC. This is equal to AS plus BQ plus CQ plus DS. Now I add AS plus DS. Now AS plus DS is AD plus BQ plus CQ. BQ plus CQ is BC. This I obtain. Now since ABCD we have taken as rectangle, AB is equal to DC. Now AB is equal to DC means I can write it 2 times AB. This is equal to now AD plus BC, and since AD and BC are equal, I can write it 2 times BC. 2 and 2 are cancelled, which gives us AB is equal to BC. Now if AB and BC are equal and BC is equal to AD, so this gives us AB is equal to BC and BC is equal to AD. So this is equal to AD and AD, and since AB is also equal to DC, so this is equal to DC. We obtain this. Means all the 4 sides of this rectangle are equal, and if a rectangle has all the sides equal, then it is a square. So therefore ABCD is a square whose all sides are equal, and this is what we are to prove, hence proved. Question number 23rd. In the given figure, DEFG is a square. Figure is this. DEFG, this is a square, means all the sides are equal. Angle BAC is equal to 90 degree. BAC, this angle is 90 degree. show that FG square is equal to BG into FC. This we have to prove. Now we see this figure. See, one triangle is ABC. This is one triangle, bigger triangle. Now we see triangle ADE. ADE, and we see triangle GDB. If we see triangle GDB, see this angle is 90 degree. Since this is a square, means this angle is also 90 degree. So A point corresponds to G. Now since this is a square, means this line is parallel to this line, means this angle is equal to this angle. Both are corresponding angles. That is, D point corresponds to point B. So D point corresponds to point B means I am to write it BD like this, and E point corresponds to point D. So both the triangles have all angles equal. So by AA similarity, we can say that these two triangles are similar triangles. Now I see triangle ADE and triangle EFC. So triangle ADE and triangle FEC. Now here I see that angle A is 90, F is having angle F is 90. So A corresponds point F, angle E. Angle E, the corresponding angle is C. Both the angles are equal because these two lines are parallel lines. So angle E corresponds to angle C. Angle E corresponds to angle C. And D corresponds to angle E. This point corresponds to this angle. So since again in both the triangles we find that all the angles are same, so AA similarity criterion, these two triangles are similar triangles. Now ADE triangle is similar to GBD triangle, and triangle ADE is similar to triangle FEC. Means these two triangles should also be similar. So triangle, this implies triangle GBD is similar to triangle FEC. Now by similarity theorems, we know if the two triangles are similar triangles, then their corresponding sides will be in proportion. So GB upon FE is equal to GD upon FC is equal to BD upon EC. This we can write. Now we have to prove this, means FG square is equal to BC into FC. So BG is this, we have to retain this, means we have to take these two. We have to take this equation. So by cross multiplying, we can write GD into FE is equal to BG, I can write GB, I can write BG into FC. By cross multiplication, I can write this. Right hand side I have obtained. Now GD into FE. See, GD is this and FE is this. Now since it is a square, all the sides are equal. So I can take any of the sides of the square. So this GD is equal to GF. So I can write GF into, again FE is also equal to GF. So GF into GF is equal to BG into FC, which gives us GF square is equal to BG into FC, and this is what we are to prove, hence proved. Now we will see the question which is given in the OR of this question. Now we will see the question which is given as OR of question number 23rd. In an equilateral triangle, prove that 3 times the square of one side is equal to 4 times the square of one of its altitude. We make the diagram. See, this is our equilateral triangle. All sides are equal, all angles are equal. Let us say this triangle is ABC. This is the altitude. Let us say this point is D. Now we take each side of this equilateral triangle as A. So this is A. This length is also A, because equilateral triangle has all sides equal. All angles are equal. Each angle is of 60 degree. And this AD is the altitude. Let us say this is equal to H. The height is equal to H. Now, since triangle ADB and ADC, we find that angle B is equal to angle C, and this is common, AD is common. This angle is 90 degree. In both the cases, ADB and ADC both are of 90 degree. So these two triangles are, and AB is equal to AC. So these two triangles are congruent triangles. That is, BD and DC both are equal. Since this total is of length A, we can take BD as A upon 2. This length is A upon 2, and this length, this side, is also A upon 2. Now we can apply Pythagoras theorem in triangle ADB. So apply Pythagoras theorem in triangle ADB. This angle is 90 degree. Here this angle is 90 degree. So hypotenuse square, that is A square, this is equal to perpendicular square plus base square, that is H square plus A upon 2 whole square. By applying Pythagoras theorem, we obtain this. This implies, simplify this, A square is equal to H square plus A square upon 4. This can be brought here to the left hand side. So A square minus A square upon 4, this is equal to H square, which gives us 3 upon 4 A square is equal to H square. That is, if we cross multiply, 4 will go to right hand side. 3A square is equal to 4 times H square. And this is what we are required to prove. What we are to prove? 3 times the square of one side. So 3 times the square of one side is equal to 4 times the square of its altitude. Altitude is H. So right hand side we are having 4H square. This is what we are to prove, hence prove.